tire pressures on a certain type of car independently follow a normal distribution with a mean 1.9 bars and standard deviation 0.15 bars. Okay, let's get that. Let's start with this. Okay, the information standard deviation I have 0.15, and then mu equals to 1.9. Okay, and then find the probability that all four tires on a car of this type have pressure between 1.82 bars and 1.92 bars. Okay, let's draw this bell curve. Okay, whenever you have a question, okay, always start with the bell curve. Okay, it doesn't have to be accurate, but this curve helps us to understand where these information lies. Okay, and then it's easy for us to find out. Okay, find the probability that all four tires on a car of this type have pressure between 1.82 to 1.92. Okay, so since the mu is 1.9, which is the mean, and then we have standard deviation, which is 0.15. So where does 1.82 lies? Okay, I'm just going to estimate that. So if it's 1.9 over here in the center, then 1.82 should be somewhere here. So it doesn't have to be accurate, but it certainly helps. Okay, but we understand that if 1.9 is in the center, then 1.8 should be towards the left, and then 1.92 should be towards the right. Okay, so somewhat like this, 1.92. Okay, now between 1.82 to 1.92. So I'll start off by finding what's the z-score. Okay, z equals to x minus mu over standard deviation. So in this case, to find the z-score, I'll take 1.92 first. Okay, 1.92 minus mu, which is 1.9 over 0.15, and the answer that I got is 0.13333 recurring. Okay, so now find the pi of 0.13333. Okay, so this pi can be found from the normal distribution table. Okay, so using MF19 you can find the answer. So I have 0.5517 and 0.3, so you add another 12, so what I have is 0.5529. Okay, so the answer is 0.5529. Okay, so this is for 1.92, whereas the z-score for 1.82, the same method. Let's do that. 1.82 minus 1.9, and 1.82 is towards the left of the mean. Okay, mu, so it should be a negative pi. Okay, or sorry, negative z-score. So 1.82 minus 1.9 over 0.15, and I'm getting negative 0.5333. Okay, so find the pi of negative z, which is same as 1 minus the pi of z. Okay, so it's 1 minus the pi of positive z, which is 0.5333, and it's 1 minus 0.7029, and the answer that I have is 0.2971. Okay, 0.2971. So now that I have the probability for 1.82, so anything below, okay, 1.82 lies over here. So this is the probability for 0.2971, and whereas the probability for 1.92 is 5529, which is from here. So okay, so this yellow region, all this yellow region, okay, that's 1.92 lower than 1.92, which is 0.5529 or 55.29%. So the question requires us find the probability between 1.82 and 1.92. So to do this, the answer will be 0.5529 minus 0.2971, and the answer is 0.2558, of approximately 0.256. Okay. Okay, the question requires us find the probability that all four tires, okay, this is probability for one tire. So if it's all four tires, then this is basically 0.256 times by 0.256 times by 0.256 times by 0.256, or another word, this is 0.256 to the power of 4, 256 to the power of 4, and the answer that I have here is 0.00428. Okay. Okay, let's look at the next part of the question. Safety regulations state that the pressures between must be between 1.9 minus B bars and the 1.9 plus B bars. It is known that 80% of the tires are within these safety limits. Okay, 80% are within this safety limit. Find the safety limits. Okay, first let's draw the bell curve. Okay, sketch a bell curve. Okay, that's the bell curve. So the question says 1.9 minus B to 1.9 plus B. So that's the safety limit. So, and we know bell curve or normal distribution curve is a symmetrical curve. Okay, and 1.9 is in the middle, that's the mu. Okay, so 0.8 or 80% is between minus 1.9 minus B and 1.9 plus B, 80%. So since it's minus B and plus B, they are equal, so I can divide it into 2. Okay, so this part here, so this can be 1.9 minus B and this is 1.9 plus B. Okay, so these value, this area, the region, the shaded region is 80% or 0.8. Okay, 80% or 0.8. Okay, so basically what I have to do, I have to find the probability of phi of negative z less than x is less than phi of positive z. Okay, why negative and positive? We know the value towards left. Okay, the standard deviation is a negative value. Okay, and then towards your positive, towards the right of mu is all positive value. So this will cover the probability or the value of between 1.9 minus B to positive 1.9 plus B. Okay, now to do this, what I'm going to do, okay, this is 40%. We know this part is 40%. Okay, that part is 40%. Okay, that's 40%, and this part is also 40%. Okay, so maybe I have to extend this up to here. Yeah. Okay, so somewhat like this. This whole thing is 40%. Okay. Okay, if this part is 40%, this part is 40%. Okay, what's left here is only 10%. What's left here is only 10%. Okay, so anytime, okay, the blue color here is 10% and 10%. So anytime, whenever we look at from 40% all the way here, so this is 40 and this is 40, this is 10. So we are looking at 90 towards left okay, of the shaded region, or towards the right of the shaded region. Okay, from here, this is 40, this is 40, and this is another 10 including, so it's always 90%, okay, on both sides. Okay, 90%. So what I can do, okay, I can take the look at um, a distribution graph, okay, normal distribution graph or table, and then find out what is the z-score for 90%. Okay, what is the z-score for 90%? Okay, z-score for 90% is, okay, 1.281. Okay, 1.281. Okay, so if it's on the right or on the left, doesn't matter. If it's on the right, then this is positive 1. Positive 1.28 1.281, or if it's just the left part, just the blue color region, that is only negative 1.281. Okay, negative just indicates the negative region, so okay, because it's on the left hand side. So using these values, okay, I can find out what is the x value, okay, or what is the b value. The question here, they don't want what's the b value, they just want to know what is the limit, okay, safety limit between 1.9 minus b to 1.9 plus b. Okay, so let's do that. So negative, first I'm going to take the left hand side. So for the left hand side, it is negative z equals to x minus mu over sigma, or standard deviation. So for the left hand side, from here we have negative 1.281 equals to x minus 1.9, okay, which is mu, over standard deviation, which is 0.15. Okay, 0.15. So x is actually 1.9 minus b. I can even substitute that with 1.9 minus b, minus 1.9 over 0.19 equals to negative 1.281. So now let's multiply this. So 0.15 times by negative 1.281 is negative 0.19215, and then this is minus b, minus 1.9, bring that over, it's plus 1.9, and this is equal to 1.9 minus b. So 1.9 minus b, okay, is equal to 1.70785, and the answer is 1.7122 decimal places. Okay, so your lower limit, okay, safety limit is 1.71, whereas your upper will be, okay, just now we took negative, now towards right we take positive. Okay, positive 1.281 equals to x minus 1.9 over 0.15. Okay, so 0.15 multiplied by 1.281 equals to x minus 1.9. X minus 1.9 is actually 1.9 plus b. Okay, that's what it means, minus 1.9, and when you multiply these two, I'm getting 0.19215, and you add that, 1.9 plus b equals to 1.9 plus 0.19215, and the answer that I'm getting is 2.09215, approximately 2.09. Okay, so yeah, I mean, if I simplify to 2.09. Okay, so for the question, they require us to find, okay, what 80% of the tires are within these safety limits. Find the safety limits. So the safety limits are 1.71 to 2.09.